Hello learners, in earlier lecture we have seen the procedure for selection of the belt. Okay, in this lecture now we'll see one example on selection of flat belt from the manufacturing catalog. So this is what our unit, chain belt and rope driver, and its outcomes are what, selection of belt from the manufacturing catalog. Okay, so either it is a V belt or flat belt. Now we are seeing it for the flat belt. Okay, the procedure for selection that we have already studied, we'll just revise it and then we'll proceed for the one example based on selection of belt from the manufacturing catalog. Okay, so you will see here that those are the things that we require for the selection of belt. Means if you are selecting a belt, so for what application you are selecting it, so you should know how much power you are going to transmit it, then what will be your input unit, what is the speed of your output unit, the center distance and type of load. Okay, those are the three input parameters that you should know. Okay, and based on these three input parameters you select a belt from the manufacturing catalog. Okay, so the procedure that we have selected or that we have used, for the in that procedure the power that we need to transmit is going to change as the loading condition will be different, as the angle of wrap will be different. Okay, so that factor, that power is going to change. So in order to change that power we use those factor, that is load correction factor that we have seen in last lecture. Then next we have seen the arc of contact factor that depends on the wrap angle of smaller pulley. Okay, and then we have seen the speed, what will be the speed of belt in case of in actual condition. Okay, when the belt is designed, okay, at that time the power transmitting capacity of that belt is decided based on the optimum velocity. Okay, and certain angle of wrap. Okay, that is 180 degree of angle of wrap and for the velocity of 5.08. but in actual situation, okay, in application, okay, that velocity might be different. Okay, so we need to modify that belt power transmitting capacity of that belt. Okay, so those are the three things that we need to modify. Okay, and this is what a standard width of the ply for different number of plies and diameter of the pulley. Then we have seen this procedure, this is what procedure that we have seen in last lecture. Okay, now we'll move to the example. Okay, so I'll just read the problem statement, I'll explain it and then we'll proceed for its solution. Though whatever the steps we have seen in selection of belt from the manufacturing catalog, the same steps you have to apply, you have to solve it. Okay, so the problem statement is what it is required to select a flat belt drive for a compressor running at 720 rpm, which is driven by what, motor of 25 kilowatt which is running at 1440 rpm. The space available for the center distance is 3 meter. The belt is a open type. Okay, so for that thing you have to design you have to select a belt from the manufacturing catalog. Okay, when you are selecting the belt, which are the four things that you require? First thing, how much power you have to transmit it, so that is given. Motor is delivering the 25 kilowatt power to the belt drive. Okay, and then it will be running a compressor. Okay, so power transmitting capacity is known. Then input speed and output speed. So your input is what, motor is your input which is running at 1440 rpm. Okay, and compressor is your output. Okay, at output shaft. Okay, so it will be running at 720 rpm. So input and output should be known to you. Okay, then type of load, what type of load will be acting over the belt. Okay, so that depends on your application, what is attached at your output shaft. Okay, based on that how much vibrations are produced over the belt. Okay, and what type of load will be acting over the belt, that will be decided. Okay, so they based on your output application. Okay, so that is your compressor. Okay, so type of load is known to you. And then next thing is center distance. So center distance is given, that is 3 meter. Okay, so those are the given things. So power is 25 kilowatt, en1 that is speed of the input, input shaft speed 14404 rpm, output shaft speed 720 rpm. Okay, and center distance is given 3 meter. Okay, then first step is what, when you know the input parameter, the first step is for finding the diameter of the pulley. Okay, so finding the diameter of the pulley, smaller pulley and bigger pulley. But how you will find out the diameter of the pulley? Basic thing. Okay, so if the belt velocity is unknown to you, okay, if the belt velocity is unknown to you, so what is that formula? That is velocity is equals to pi dn by 60. Okay, if you know the velocity, okay, if you know the speed, then you can find out the diameter. Okay, but here if belt velocity is unknown to you, then how could you proceed for finding the diameter of the smaller pulley? Okay, that is the biggest questions. Okay, so for that thing, what you can do, you know that optimum belt velocity for the belt selection from the Dunlop manufacturing catalog is what? 17.8 meter per second to uh, 22.9 meter per second. So that is what a velocity range, optimum velocity range. Okay, so you have to select a average velocity of means or any value in between those. Okay, so that is 17.8 meter per second to 22.9 meter per second. In between that value you can take any value as a belt velocity, and then based on that you can find out the diameter of the belt. Okay, so here I'm selecting 18 meter per second as a belt velocity, so rounded off value I am taking in order to avoid the calculations. Okay, so I am taking an 18 meter per second as a belt velocity. So based on that, if I just manipulate it, so you will comes to that diameter is equals to what? Diameter is equals to power. Okay, diameter is equal to 60 into power by pi into speed. Okay, so if you put that values over here, you will get the diameter of the smaller pulley. Okay, if you know when you will get a diameter of smaller pulley, but you have to again see whether that diameter is lying between the standard diameter range or not, that is preferred diameter range or not. So you have to modify. Suppose your value of smaller diameter is what? 238.73 mm. Okay, so you have to see whether that value is lies in standard diameter or not. If it is not, then go for the next preferred value closer to that value. Okay, so that is 250 mm diameter of the pulley, so that you have selected. Okay, and then next is next diameter is next you have to find out the diameter of the bigger pulley. Okay, so diameter of bigger pulley is what? Diameter of smaller pulley into input speed upon output speed. If you put those values, you will get a diameter of bigger pulley. Okay, so you will get diameters of the pulleys. Then next thing is what? Next thing you have to find out. Now that velocity you have assumed. Okay, now what you have to do, you have to find out for these values of diameter what will be the velocity. Okay, what will be the velocity of that belt. Okay, so again you have to go reverse. Okay, so you have to put the diameter of smaller pulley in that formula. V is equal to pi d n by 60, okay, into 10 cube. That will give you in meter per second, and that velocity should lie in optimum velocity range. So optimum velocity range is what? 17.8 meter per second to 22.9 meter per second. So calculated value is 18.85, so that will be in between that optimum range. That means whatever the diameter you have find out, those are appropriate for your application, because it will be running with an optimum velocity. Okay, so your power means your power transmission will be more efficient. Okay, so this is what your first step. Then next step, second step is what? Maximum power for selection. Means you have to calculate a maximum power. Okay, now you know the rated power. That motor is running at 25 kilowatts, so it will be transmitting that power to the belt. But whether your device will be transmitting that much load, or it require more than that load, because uh, there is some vibration will be there over the drive, then angle of wrap will be different. So you need might be okay, you need more than that power or lesser than that. So you have to find out how much maximum power you need to transmit, okay, based on your rated power. So your maximum power is what? Maximum power is equal to FA, that is load correction factor into power. Okay, transmitted power. Okay, so now F is load correction factor that you will get from type of load. So you know the type of load, what type of load will be acting over the belt. So it will based on your application. Okay, now you have to run your compressor by using a motor. So the whatever the vibrations are produced at the output shaft, that will be transmitted to your belt. Okay, and that will contribute to the consumption of power. Okay, got it. So you have to, for that thing you have to uh, based on type of load that you will get from output, what will be unit which is attached at output. So from there you will get a load correction factor. So for the compressor, it is load correction factor is 1.3. so maximum power is what? 1.3 into transmitted power. Transmitted power is your 25 kilowatt, so you will get maximum power, that is 32.5 kilowatt. Okay. Then next third step is what? Arc of contact factor. You have to find out an arc of contact factor because your in your application the angle of wrap might not be 180 degree, it might be lesser than that or greater than that. Okay, so in order to do that you have to find out an arc of contact factor. Okay, because if angle of wrap will be lesser, then more tension will be there in the belt. Okay, so you need to put a more tension in the belt in order to transmit power. Okay, because if your angle of wrap will be more, it will transmit more power. Okay, if your angle of wrap will be smaller, then you have to you have to give a tension to the belt, so it will transmit a more power. So for calculating arc of contact, you have to first find out the angle of wrap of smaller pulley. So that is given by formula alpha s is equals to 180 minus 2 into sine inverse d minus d upon 2c. So here by that formula you will get angle of wrap, that is 175.23, that will be angle of wrap. If you find out the arc of contact factor corresponding to that angle 175.23 degree, but it is not standard value, non-standard value. So what you have to do, you have to use in linear interpolation and you have to find out the arc of contact factor, that is FD, corresponding to 175.23 degree. Your angle of arc of contact factor is what? 1.019. Okay. Then next step is corrected power. You have to find out a corrected power because your arc of contact was different than 180 degree. Okay, if it is 180 degree, then there is a factor, that is FD will be one value 1. Okay, and your power, maximum power, is equals to corrected power basically. Okay, but angle of wrap will be different, so your power transmitted will be different, or corrected power will be different. So your corrected power is equals to what? FD into maximum power, so you will get a corrected power. Okay, next thing is what? Corrected power rating. You have to find out the corrected power rating. Okay, so corrected power rating is what? For the high speed belt, you know, power rating is given for the high speed belt, also for the dug belt. Okay, high speed belt and your Ford belt will be given. Okay, so that is 0.0118 kilowatt per width. Okay, per ply. That means if you have one ply whose width is 1 okay, and that single ply, how much power it can transmit? 0.0118 if it is high speed belt. Okay, if it is high speed belt. And now if it is Ford belt, that power will be 0.0147 kilowatt. Okay, so now you have to find out the corrected power rating. So corrected belt rating or power rating is what? Corrected power rating is how much power that belt can transmit into its velocity, which actual velocity which is running, and the belt velocity, that is standard belt velocity, that is 5.08. so from that formula you will get an corrected belt rating, so that is 0.0438 kilowatt. Okay, the next step is finding the width of the belt. Width of belt is what? Width of belt is corrected power upon corrected power rating. So corrected power we have calculated in fourth step, and corrected power rating we have calculated in fifth step. If you take the ratio, you will get a width into number of ply, that is product. Okay, width into number of ply. Now we don't know how many number of plies we are using, we don't know, we have to calculate the width. So what you can do, you can assume the number of ply. Suppose initially I am assume 4 number of plies. Okay, so I'll put a value of number of plies 4, and then I will get width is equals to that 756 divided by 4, so that is nothing but 189.04 Similarly, I am assuming 5 plies and so on. Okay, I will assume number of plies which are available in catalog. Okay, and I'll find out the width, and from that value, okay, from that value of width, I'll check in standard catalog that for the four number of ply, my width is 189.04 so is it closer to the standard value or not? Or for the 5 plies my value is 151.23 is it closer to the standard value or not, and so on. I'll check it for the number of possibilities, that is 4 ply, 5th ply, 6th ply, and so on. Okay, this is trial and error. Okay, so I'll do that thing from that trial. I'll do, and I found that for the for 5 number of plies my width is what? 151.23, which is very closer to the standard value of 5 plies in catalog. That is value is what? 152. that means 151.23 is very closer to 152. Okay, for the 4 number apply it is 189.05, but in standard value it is 185 something. Okay, so that there is variation, okay, large variation, but in case of the 5 place my value is very closer, so I'll assume the 5 place only, and for the 5 place my standard value is 152 mm. So this is what my answer, width of the ply is what, 152 mm. Okay, so that way you can find out. And this is last step, that is length of the belt. So length of the belt you can calculate by formula. This is open belt drive. Okay, so the formula for open belt drive is equals to 2 plus 2c plus that one. Okay, so that formula, put those values, you will get a length, and from the catalog you will find out the standard uh, length of the belt. Okay, if it is a cross belt, the new formula here, instead of minus it will be plus d plus 2 d plus d square upon 4c, last term will be different. Okay, so that way you can find out all values. Thank you. If you have any query, put it on discussion forum, so I'll answer those queries. Okay, and if you still any doubt, just let me know, so I'll again make one video and I'll elaborate it in deep. Okay, thank you. I refer those things, and there's some videos of NPTEL is also available for this. Okay, so you can refer those videos. Thank you.